Venus, the planet named after the Roman goddess of love and beauty, has intrigued humanity for centuries. However, beneath its name's gentle connotations, Venus is far from the tranquil and serene entity one might imagine. In fact, it is one of the most hostile and enigmatic planets in our solar system. This world of extremes harbors a deadly cocktail of mysteries, many of which remain unsolved. Its harsh atmosphere, blistering temperatures, and strange surface features offer scientists countless questions, and yet the answers remain elusive. But before we continue, if you like this type of videos, please subscribe to the channel and comment. The story of Venus is as dramatic as any other celestial body, shrouded in intrigue and clouded, literally, by an impenetrable atmosphere that defies all attempts to see through it. What is happening beneath Venus's clouds? How did this planet, once thought to be Earth's twin, evolve into such an inhospitable world? These are some of the burning questions we must explore, and as we unravel the complex nature of Venus, we may discover answers that extend far beyond this planet alone. Venus may hold keys to understanding planetary evolution, climate change, and even the possibility of life beyond Earth. To appreciate Venus in its entirety, we must first consider its position in the cosmos. Venus is the second planet from the Sun, orbiting at an average distance of 108 million kilometers, 67 million miles. Its proximity to the Sun accounts for some of the extreme temperatures on its surface, but Venus's atmosphere takes the heat to unimaginable levels. With surface temperatures reaching a staggering 475 degrees Celsius, 900 degrees Fahrenheit, it is the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. This paradox, of being further from the Sun yet hotter, immediately raises one of the great mysteries of Venus. What caused such an extreme greenhouse effect? Scientists now understand that Venus's thick atmosphere, composed primarily of carbon dioxide, traps heat in a runaway greenhouse effect. However, the magnitude of this effect is beyond anything we experience on Earth. Its clouds are made of sulfuric acid, making the atmosphere toxic and corrosive. Lightning frequently strikes across the planet, and winds at the upper levels of its atmosphere scream around the globe at hurricane-force speeds. The pressure on the surface of Venus is about 92 times that of Earth, equivalent to the pressure you would experience if you were a kilometer deep under Earth's oceans. It's a hellish environment, yet Venus wasn't always this way, or at least, that's what scientists believe. The early history of Venus is one of the planet's most tantalizing mysteries. There is a growing body of evidence suggesting that Venus may have once had conditions suitable for liquid water, perhaps even oceans. If Venus did indeed have water, it may have had the potential for life, making its transformation into the furnace it is today all the more tragic and mysterious. What happened to Venus's water, and what caused the planet's climate to veer so dramatically? Some scientists suggest that Venus experienced a catastrophic event that set off its runaway greenhouse effect, while others believe its slow rotation played a critical role. Unlike Earth, which rotates on its axis in 24 hours, Venus takes 243 Earth days to complete one full rotation. Even stranger, Venus rotates in the opposite direction to most planets, meaning the Sun rises in the west and sets in the east. These odd characteristics contribute to the many unknowns surrounding Venus's climate history. The surface of Venus, hidden beneath those dense clouds, offers even more enigmas. Thanks to radar mapping by missions like NASA's Magellan spacecraft, we've been able to glimpse the topography of this shrouded world. Venus's surface is dominated by vast plains covered with volcanic rock, mountain ranges that soar higher than Mount Everest, and deep canyons. Volcanism appears to have played, and perhaps still plays, a crucial role in shaping Venus's landscape. Unlike Earth, Venus doesn't have tectonic plates that constantly shift and move. Instead, it seems that Venus's crust is a single, unbroken shell. So, what drives the planet's volcanic activity? Are Venus's volcanoes still active today? There are signs that Venus may still be geologically active. Some scientists point to changes in Venus's atmospheric composition, which could be caused by volcanic eruptions. Additionally, radar images have captured surface changes over time that suggest fresh lava flows. If Venus is still volcanically active, it would have profound implications for our understanding of the planet's interior and its overall geologic history. But perhaps the most tantalizing question of all is whether life could ever have existed on Venus, or might still exist high above the planet's hellish surface. In 2020, scientists made a shocking discovery: the presence of phosphine gas in Venus's atmosphere. On Earth, phosphine is produced by biological processes, raising the possibility that microbial life could be thriving in the planet's upper cloud layers, where temperatures and pressures are much more Earth-like. This revelation reignited interest in Venus as a potential host for extraterrestrial life, though much skepticism remains. Some researchers believe that phosphine could have non-biological origins, perhaps linked to unknown chemical processes in Venus's clouds. However, the detection of phosphine remains one of the most exciting space discoveries in recent years, and it has led to renewed calls for missions to Venus to investigate further. The quest to explore Venus has been challenging due to its harsh environment. Only a handful of spacecraft have successfully landed on its surface, and those that did survived for mere minutes before succumbing to the crushing pressure and heat. The Soviet Union's Venera program was the most successful, with Venera 13 transmitting the first color images from Venus's surface in 1982. Despite the extreme conditions, these missions provided invaluable data about Venus's atmosphere and surface, revealing a barren, rocky landscape unlike anything we had imagined. More recent missions have focused on studying Venus from orbit, using radar to map its surface and instruments to analyze its atmosphere. But direct exploration remains difficult, and many mysteries about Venus continue to elude us. In recent years, there has been growing interest in sending more missions to Venus. NASA, the European Space Agency, and other space agencies are planning missions that aim to unlock some of the planet's secrets. Proposed missions include atmospheric probes that could search for signs of life in Venus's clouds, landers that could explore the surface in more detail, and orbiters that would map the planet with even greater precision. These missions could help answer some of the most fundamental questions about Venus's past, present, and future. Did Venus ever have liquid water? If so, what caused it to disappear? Is there life in Venus's atmosphere? And could Venus hold clues to the future of Earth's own climate? While Venus is often overshadowed by more glamorous celestial objects like Mars or the moons of Jupiter and Saturn, it remains one of the most important planets for scientists to study. Venus is often called Earth's evil twin because of its similar size and composition, yet its dramatically different climate provides a cautionary tale about the potential consequences of a runaway greenhouse effect. Studying Venus could give us critical insights into the fate of Earth's climate and atmosphere, especially as we face the challenges of global warming. Understanding how Venus went from a potentially habitable world to the scorching inferno it is today could help us prevent a similar fate for our own planet. Venus's atmosphere is undoubtedly one of the most puzzling aspects of the planet. With its thick carbon dioxide layer and clouds of sulfuric acid, this atmosphere creates an environment unlike anything found elsewhere in our solar system. The upper layers of Venus's atmosphere are relatively cool, with temperatures hovering around 30 to 70 degrees Celsius, 86 to 158 degrees Fahrenheit, similar to temperatures found in some parts of Earth. However, as you descend through the atmosphere, conditions rapidly worsen. The pressure increases, and temperatures soar until you reach the surface, where the heat is enough to melt lead. The sulfuric acid clouds that obscure Venus's surface are a key factor in this extreme greenhouse effect. These clouds are highly reflective, meaning they reflect much of the sunlight that hits the planet back into space. However, the carbon dioxide in the atmosphere traps the heat that does make it through, creating a feedback loop that has caused Venus's temperature to rise over time. This runaway greenhouse effect is one of the greatest mysteries of Venus. How did the planet reach such an extreme state? Was it always this way, or did some catastrophic event trigger this dramatic climate shift? Some scientists believe that Venus once had a much more temperate climate, with oceans of liquid water on its surface. If true, this would have made Venus a prime candidate for hosting life in the distant past. However, as the sun gradually brightened over billions of years, Venus's oceans may have evaporated. The water vapor would have entered the atmosphere, contributing to the planet's greenhouse effect. Water vapor is a potent greenhouse gas, and as more water entered the atmosphere, the surface temperature would have risen even further, causing a feedback loop that ultimately led to the extreme conditions we see today. This theory, while compelling, raises even more questions. If Venus once had water, why did it lose it? Did volcanic activity play a role? And perhaps most importantly, could something similar happen to Earth? Venus may serve as a warning about the fragility of planetary environments. The delicate balance between atmospheric composition, solar radiation, and surface conditions can be easily disrupted, leading to catastrophic consequences. By studying Venus, we may gain insights into the processes that could one day threaten our own planet. One of the biggest mysteries about Venus's atmosphere is its superrotation. The planet's atmosphere rotates much faster than its surface. While Venus itself takes 243 Earth days to complete one rotation, its upper atmosphere whips around the planet in just 4 Earth days. This phenomenon is known as superrotation, and it's something scientists are still trying to fully understand. The cause of this superrotation is likely tied to Venus's unique atmospheric dynamics, but the exact mechanisms remain unclear. The atmospheric winds that drive this rotation are incredibly powerful, reaching speeds of up to 360 km per hour, 224 miles per hour. These winds circulate in the upper atmosphere, creating a complex system of vortices and jet streams that are unlike anything seen on Earth. Scientists have speculated that these winds are driven by a combination of solar heating and the planet's slow rotation, but many details remain a mystery. Why is Venus's atmosphere moving so much faster than the planet itself? What forces are driving this superrotation, and how does it affect the planet's climate? Further complicating the picture is the discovery of gravity waves in Venus's atmosphere. These waves, which are different from gravitational waves that ripple through spacetime, are atmospheric disturbances caused by the interaction between the surface and the atmosphere. Gravity waves have been observed on Earth, often in mountain ranges or over oceans, but on Venus, they seem to play a much larger role in shaping the planet's weather patterns. These waves may be responsible for the strange cloud formations seen on Venus, and could provide clues to the planet's atmospheric dynamics. Understanding these waves could help unravel the mysteries of Venus's superrotation and give us new insights into how atmospheres behave under extreme conditions. But the mysteries of Venus are not confined to its atmosphere. The planet's surface, although hidden beneath thick clouds, is equally enigmatic. Thanks to radar mapping, scientists have been able to get a sense of what lies beneath the clouds, and what they've found is nothing short of remarkable. Venus's surface is dominated by vast volcanic plains, indicating that volcanic activity has played a major role in shaping the planet. There are also towering mountains, deep valleys, and mysterious circular features called coronae that are unlike anything seen on Earth. Volcanism appears to be one of the defining features of Venus. The planet is dotted with volcanoes, some of which are larger than any found on Earth. One of the most prominent volcanic features on Venus is Maxwell Montes, the highest mountain on the planet. Rising over 11 kilometers, 7 miles, above the surface, Maxwell Montes is a towering reminder of Venus's geological power. But perhaps the most intriguing aspect of Venus's volcanism is the question of whether it is still active today. There is growing evidence to suggest that Venus may still be volcanically active. In 2020, scientists discovered signs of recent volcanic activity on Venus, indicating that the planet is not as geologically dead as previously thought. This discovery has profound implications for our understanding of Venus's interior. If Venus is still active, it would mean that the planet's mantle is still convecting, driving heat from the interior to the surface. This heat could be responsible for the planet's extreme surface temperatures, and may even play a role in its atmospheric dynamics. Venus's volcanic history is also tied to one of its most mysterious features, tesserae. These are large, crumpled regions of the planet's surface that appear to have been shaped by tectonic forces. Tesserae are among the oldest surface features on Venus, and they offer clues to the planet's geological past. Some scientists believe that tesserae could be remnants of an ancient tectonic system, similar to Earth's plate tectonics. However, Venus lacks the plate tectonics that drive geological activity on Earth today, so how these features formed remains a mystery. Adding to the mystery is the fact that Venus's surface appears to be relatively young. Radar data suggests that Venus's surface is only about 300 to 500 million years old, much younger than other rocky planets like Mars or Earth. This raises the question, what happened to Venus's older surface? Did some cataclysmic event resurface the planet, burying its ancient history under layers of lava? Or has Venus undergone a series of resurfacing events throughout its history, erasing evidence of its past? These questions remain unanswered, and they add another layer of complexity to the enigma of Venus. One of the most intriguing discoveries about Venus's surface is the presence of coronae, large, circular structures that are thought to be the result of upwelling plumes of hot material from the planet's mantle. These coronae are unique to Venus and are unlike anything seen on Earth. Some scientists believe that coronae are evidence of a different type of tectonic activity on Venus, one driven by the planet's unique conditions. However, the exact mechanisms behind their formation are still not well understood. What we do know is that coronae provide a tantalizing glimpse into the inner workings of Venus, and they could hold the key to unlocking some of the planet's greatest mysteries. As we continue to study Venus, new discoveries are being made that challenge our understanding of the planet. For example, recent data from the European Space Agency's Venus Express mission has revealed that Venus's polar regions are much colder than previously thought. These cold spots, known as polar vortices, are caused by complex atmospheric dynamics and have added a new dimension to our understanding of Venus's climate. The polar vortices are incredibly stable, remaining in place for years at a time, and they rotate much more slowly than the rest of the planet's atmosphere. This strange behavior has left scientists puzzled, and it raises even more questions about how Venus's atmosphere functions. The mysteries of Venus extend beyond its atmosphere and surface, touching on the fundamental processes that govern planetary evolution. One of the biggest questions is whether Venus ever had liquid water. If Venus did once have oceans, as some models suggest, it could have been a very different planet in its early history. Liquid water is essential for life as we know it, and if Venus had water, it raises the tantalizing possibility that life could have once existed there. But what happened to Venus's water, and why did it disappear? Scientists believe that Venus's proximity to the Sun caused its water to evaporate, but the exact details remain unclear. One possibility is that Venus experienced a phenomenon known as a moist greenhouse. In this scenario, as the Sun brightened over time, Venus's oceans began to evaporate, releasing water vapor into the atmosphere. This water vapor, being a powerful greenhouse gas, would have trapped more heat, causing the surface temperature to rise. Eventually, the heat would have been sufficient to break down water molecules, allowing hydrogen to escape into space. Over time, this process would have stripped Venus of its water, leaving the dry, desolate world we see today. The hypothesis of Venus once having water is further supported by the planet's geological features. Some researchers suggest that the smooth plains on Venus may have been shaped by the flow of liquid water in the distant past. However, without direct evidence, this remains a theory. If water did exist on Venus billions of years ago, understanding how it was lost is crucial, not just for understanding Venus but for assessing the future of Earth. As our Sun continues to increase in brightness over time, could Earth face a similar fate? Venus, in this sense, may offer a preview of what happens when a planet's delicate equilibrium between its atmosphere, surface, and the energy it receives from its star is disrupted. In addition to water, scientists are also investigating the possibility of life on Venus, particularly in its atmosphere. While the surface of Venus is far too hostile to support life as we know it, the upper atmosphere is much more temperate. In 2020, a team of scientists announced the detection of phosphine in Venus's atmosphere. Phosphine is a molecule that, on Earth, is primarily produced by biological processes. This discovery set off a wave of speculation that there might be microbial life high in Venus's clouds, where the temperature and pressure are much more Earth-like. However, the discovery of phosphine remains highly controversial. Subsequent studies have cast doubt on the initial findings, and there is still no definitive proof that the gas is present in significant quantities. Even if phosphine is confirmed, it could have non-biological origins, such as volcanic activity or chemical reactions in Venus's atmosphere. Nonetheless, the possibility of life in Venus's atmosphere is one of the most exciting avenues of research in planetary science. If life can exist in the harsh conditions of Venus, it would suggest that life is far more resilient and adaptable than we previously thought, opening up the possibility of finding life in other extreme environments throughout the universe. The mystery of Venus's potential for life doesn't end with phosphine. Scientists are also exploring other gases in the atmosphere that could be indicators of biological activity, such as ammonia and sulfur compounds. Some researchers have proposed that microbial life could exist in the droplets of sulfuric acid that make up Venus's clouds. These microbes would need to be incredibly hardy, capable of surviving in an environment that is both acidic and lacking in liquid water. If life is indeed present on Venus, it would represent a completely new form of life, one that has evolved to thrive in conditions that are utterly alien to anything found on Earth. Aside from the search for life, Venus's atmosphere presents other unsolved mysteries. One of the most puzzling is the planet's unusual rotation. Venus rotates in the opposite direction to most planets in the solar system, including Earth. This means that on Venus, the Sun rises in the west and sets in the east. Moreover, Venus's rotation is incredibly slow. It takes 243 Earth days for the planet to complete one rotation, making a day on Venus longer than a year. The reason for Venus's retrograde rotation is still not fully understood. Some scientists believe that a massive impact early in the planet's history could have caused it to flip over, while others suggest that gravitational interactions with the Sun and other planets might be responsible. Adding to the strangeness is the fact that Venus's rotation is gradually slowing down. Data from NASA's Magellan mission in the 1990s showed that Venus's day was getting longer by about 2 minutes every decade. The cause of this deceleration is unknown, but it could be related to interactions between Venus's dense atmosphere and its surface. As the atmosphere circulates, it exerts a drag on the planet's rotation, slowly slowing it down over time. This interaction between the atmosphere and the planet's rotation is another piece of the puzzle that scientists are working to understand. Another intriguing mystery is Venus's magnetic field, or rather, the lack thereof. Unlike Earth, which has a strong magnetic field generated by the movement of molten iron in its core, Venus has only a weak, patchy magnetic field. This is surprising because Venus is similar in size and composition to Earth, and it should theoretically have a similar magnetic field. The absence of a strong magnetic field on Venus raises questions about the planet's internal structure. Does Venus have a solid core, or is its core no longer convecting? If Venus's core has cooled and solidified, this could explain the lack of a magnetic field, but it would also imply that the planet's interior is geologically dead. The lack of a magnetic field also has important implications for Venus's atmosphere. On Earth, the magnetic field helps protect the atmosphere from being stripped away by the solar wind, a stream of charged particles emitted by the Sun. Without a magnetic field, Venus's atmosphere is exposed to the full force of the solar wind, which could be one reason why the planet has lost so much of its water over time. Understanding why Venus lacks a magnetic field is crucial for understanding the planet's history and evolution. One of the most intriguing and haunting mysteries of Venus is its potential as a mirror for Earth's future. Venus and Earth are often called sister planets because of their similar size, mass, and composition. However, the two planets have taken dramatically different evolutionary paths. While Earth has remained habitable for billions of years, Venus has become a scorching, inhospitable world. What caused these two planets, so similar in their origins, to diverge so drastically? This is one of the central questions driving research into Venus, and it has profound implications for understanding the long-term stability of Earth's own climate and atmosphere. Venus's atmosphere is thick with carbon dioxide, and its surface temperature is hot enough to melt lead. These extreme conditions are the result of a runaway greenhouse effect, where the planet's atmosphere traps more and more heat, preventing it from escaping back into space. Many scientists believe that Venus may have once had a more Earth-like climate, with oceans of liquid water and a stable atmosphere. However, at some point in its history, a tipping point was reached, and the greenhouse effect spiraled out of control, turning the planet into the hellish world it is today. The runaway greenhouse effect on Venus serves as a cautionary tale for Earth. As humans continue to emit greenhouse gases into our atmosphere, there is growing concern that we could trigger a similar, though less extreme, process on our own planet. While Earth's climate is much more stable than Venus's, the parallels are hard to ignore. Studying Venus's climate history could help scientists better understand the risks of climate change on Earth and the factors that could push our planet toward a Venus-like future. In addition to its climate, Venus's geological activity, or lack thereof, is another area of intense study. For a long time, scientists believed that Venus was geologically dead, with no active volcanoes or tectonic activity. However, more recent evidence suggests that the planet may still be geologically active. In 2020, researchers announced that they had identified more than 30 volcanic structures on Venus that appeared to be recently active. This was based on data from the Magellan mission, which mapped the surface of Venus in the 1990s. These findings suggest that Venus may still have active volcanoes, which could be releasing gases into the atmosphere and influencing the planet's climate. Understanding Venus's volcanic activity is crucial for piecing together the planet's geologic history. If Venus is still volcanically active, it would imply that the planet's interior is not completely cooled and that its core may still be partially molten. This could also provide clues about why Venus lacks a magnetic field. If the core is molten but not convecting, it could explain the weak or absent field. Volcanic activity could also be a key factor in understanding the planet's atmosphere. Volcanoes release gases like sulfur dioxide, which can form clouds and influence the climate. On Earth, volcanic eruptions can have both short-term and long-term effects on the climate, and it's possible that similar processes are at work on Venus. Venus's volcanic history also raises questions about its surface. The planet's surface is relatively young, geologically speaking, with an average age of about 300 to 500 million years. This is much younger than the surfaces of other rocky planets, like Mars or Mercury, which have surfaces that date back billions of years. The young age of Venus's surface suggests that the planet underwent a massive resurfacing event in the recent past, where much of the planet's crust was melted and reformed. What caused this resurfacing event is still a mystery. Some scientists believe that Venus's thick atmosphere may have insulated the planet, trapping heat beneath the surface until it built up to the point where the entire surface melted. Others suggest that Venus's lack of plate tectonics may have caused a buildup of heat in the planet's interior, leading to periodic catastrophic resurfacing events. The lack of plate tectonics on Venus is another enigma. On Earth, the movement of tectonic plates is a key driver of geological activity, including earthquakes, volcanoes, and the formation of mountains. Plate tectonics also play a crucial role in regulating Earth's climate by cycling carbon between the atmosphere and the planet's interior. On Venus, however, there is no evidence of plate tectonics. The planet's crust appears to be a single, unbroken shell, which may be one reason why Venus's interior has been able to retain so much heat. Without the movement of tectonic plates to release heat, Venus's interior may have reached temperatures high enough to cause the massive resurfacing event mentioned earlier. The absence of plate tectonics on Venus is puzzling because the planet is so similar to Earth in size and composition. One theory is that Venus's thick atmosphere has prevented plate tectonics from developing. On Earth, the movement of tectonic plates is partly driven by the presence of water in the planet's crust, which helps to lubricate the plates and allows them to move. If Venus lost its water early in its history, this could have prevented plate tectonics from ever getting started. Alternatively, Venus may have once had plate tectonics, but the process may have shut down as the planet's interior cooled and its atmosphere thickened. Venus's atmosphere also plays a role in another strange phenomenon, the planet's superrotation. While Venus's surface rotates very slowly, with a day lasting 243 Earth days, its upper atmosphere whips around the planet at speeds of up to 360 km per hour. This means that the clouds in Venus's atmosphere complete a full rotation in just 4 Earth days, far faster than the planet itself rotates. This phenomenon, known as superrotation, is not fully understood. Some scientists believe that it may be driven by the planet's thick atmosphere and the strong temperature gradient between the equator and the poles. However, the exact mechanisms behind superrotation remain a mystery. The mysteries of Venus extend to its interaction with the solar wind. As mentioned earlier, Venus lacks a strong magnetic field to protect its atmosphere from the solar wind, a stream of charged particles emitted by the Sun. This makes Venus's atmosphere vulnerable to being stripped away by the solar wind, a process known as atmospheric escape. Over time, this process could have contributed to the loss of Venus's water and other volatile compounds. However, Venus's thick atmosphere has persisted despite this, suggesting that there may be other factors at play. Understanding how Venus's atmosphere interacts with the solar wind could provide important clues about the planet's long-term atmospheric stability. One of the most tantalizing questions about Venus is whether it could have ever supported life. While the planet's current conditions are far too extreme for life as we know it, there is growing evidence that Venus may have once had a more Earth-like climate, with liquid water on its surface. If Venus had liquid water, it is possible that microbial life could have evolved in the planet's oceans or lakes. However, if life did exist on Venus, it would have faced a difficult battle for survival as the planet's climate changed. As Venus's atmosphere thickened and its surface temperature skyrocketed, any life that existed on the surface would have been driven to extinction. However, some scientists speculate that life could have found refuge in the planet's upper atmosphere, where conditions are more temperate. If microbial life exists in Venus's clouds today, it would represent one of the most extraordinary discoveries in the history of science. The potential for life on Venus, both past and present, is one of the driving forces behind current and future missions to the planet. In the coming decades, space agencies like NASA and ESA plan to send new missions to Venus to study its atmosphere, surface, and geology in greater detail. These missions will provide critical data that could help solve some of the planet's most enduring mysteries, from its runaway greenhouse effect to its potential for life. One of the upcoming missions is NASA's Da Vinci Plus mission, which is set to launch in the 2030s. This mission will send a probe through Venus's thick atmosphere, collecting data on its composition, temperature, and pressure as it descends to the surface. By studying the atmosphere in situ, scientists hope to gain new insights into the processes that have shaped Venus's climate and whether conditions in the upper atmosphere could support life. ESA's Envision mission is also set to launch in the next decade. This mission will use radar and other instruments to map Venus's surface in unprecedented detail. By studying the planet's geology, scientists hope to learn more about its volcanic activity, tectonics, and the processes that have shaped its surface. Envision will also investigate the possibility of recent volcanic activity, which could have important implications for Venus's atmosphere and climate. One of the most exciting aspects of Venus exploration is the possibility of detecting biosignatures in its atmosphere. In September 2020, an announcement created a flurry of excitement in the scientific community and the public alike. Researchers claim to have detected phosphine in Venus's atmosphere. Phosphine is a molecule that, on Earth, is primarily associated with biological processes. While it can also be produced through some industrial or geological processes, the detection of phosphine on Venus raised the possibility that some form of life could be present in the planet's cloud layers. The detection of phosphine is still a matter of debate. Some scientists have questioned whether the signal detected by the telescopes was actually phosphine, or whether it might have been another molecule misidentified due to the limitations of the equipment used. Others argue that even if phosphine is present, it could be produced by non-biological processes unique to Venus's harsh environment. Nonetheless, the discovery reignited interest in Venus as a potential location for life beyond Earth and prompted calls for more detailed study of the planet's atmosphere. If life does exist on Venus, it would likely be in the form of extremophiles, microorganisms that can survive in extreme environments. On Earth, extremophiles are found in some of the most inhospitable places, such as deep-sea hydrothermal vents, acidic hot springs, and even inside nuclear reactors. The upper atmosphere of Venus, while extremely acidic due to the presence of sulfuric acid, has temperatures and pressures that are much more Earth-like than the surface of the planet. Some scientists speculate that microbial life could survive in the relatively temperate cloud layers, suspended in droplets of sulfuric acid. Even if life does not currently exist on Venus, the possibility that it might have existed in the distant past cannot be ruled out. If Venus once had oceans, as some models suggest, it could have been a habitable world billions of years ago, when the Sun was younger and cooler. However, as the Sun grew hotter and Venus's atmosphere thickened, the planet's water would have evaporated, and any life present on the surface would have been wiped out. The question of life on Venus is just one of the many mysteries that researchers are eager to solve. Another mystery lies in Venus's atmospheric dynamics. The planet is shrouded in thick clouds of sulfuric acid, which obscure the surface and make it difficult to study from space. These clouds also play a key role in the planet's extreme climate, reflecting sunlight and trapping heat. Understanding the formation and behavior of Venus's clouds is crucial for understanding the planet's climate history and the processes that led to its runaway greenhouse effect. In recent years, scientists have also turned their attention to Venus's mysterious high-altitude haze. This haze, which is composed of tiny particles suspended in the upper atmosphere, appears to absorb ultraviolet light in a way that cannot be explained by known chemicals. Some researchers have suggested that the particles in the haze could be biological in origin, while others believe they could be the result of unknown chemical reactions taking place in Venus's atmosphere. The exact composition and role of this haze remain unknown, but it could hold important clues about the planet's climate and atmospheric chemistry. The study of Venus is not just about the past or present, it also has implications for the future. As humanity looks toward colonizing other planets, Venus is often overlooked in favor of Mars, which is considered more hospitable. However, some researchers believe that Venus could be a viable target for colonization if we can find ways to mitigate its extreme conditions. One proposed idea is to build floating cities in the planet's upper atmosphere, where temperatures and pressures are similar to those on Earth. These floating cities would be suspended in the clouds, above the planet's scorching surface, and could be powered by solar energy. While this idea may sound like science fiction, it has sparked serious discussions about the potential for human habitation on Venus. The exploration of Venus is also closely tied to the broader search for exoplanets, planets outside our solar system. As telescopes become more advanced, scientists are discovering an increasing number of exoplanets that are similar in size and composition to Venus. By studying Venus in detail, researchers hope to gain a better understanding of the factors that determine whether a planet becomes habitable or uninhabitable. This knowledge could help us identify exoplanets that are more likely to support life and better understand the conditions that make a planet habitable. One of the key factors in determining a planet's habitability is its distance from its parent star. Venus is located just inside the inner edge of the Sun's habitable zone, the region where conditions are right for liquid water to exist. This makes Venus a prime example of what is sometimes called a runaway greenhouse planet, a world that starts out in the habitable zone but eventually becomes too hot for life due to the buildup of greenhouse gases. By studying Venus, scientists hope to learn more about the processes that drive planetary climates and the conditions that can push a planet out of the habitable zone. The lessons we learn from Venus could also have important implications for our understanding of Earth's future. As the Sun continues to age, it will grow hotter, and the habitable zone will gradually shift outward. Eventually, Earth will find itself in a similar position to Venus, with rising temperatures and a thickening atmosphere. While this process will take billions of years, studying Venus could help us understand the long-term fate of Earth and the factors that could influence our planet's climate over geological time scales. In addition to its scientific significance, Venus holds a special place in human culture. The planet has been known since ancient times. In Roman mythology, Venus was the goddess of love and beauty, and the planet was named in her honor. The bright, shining appearance of Venus in the night sky has made it a symbol of beauty and mystery throughout history. In many ways, the mysteries of Venus today are just as captivating as they were to ancient stargazers. The exploration of Venus is still in its early stages. While past missions like NASA's Magellan and the Soviet Union's Venera program have provided valuable data, there is still much we don't know about the planet. Future missions like Da Vinci Plus and Envision promise to unlock new secrets and provide a deeper understanding of Venus's geology, atmosphere, and potential for life. As we continue to explore this enigmatic world, we may find that Venus holds the key to answering some of the most profound questions about the origins and future of life in the universe. The exploration of Venus continues to push the boundaries of our understanding, not only of the planet itself but also of the broader processes that govern planetary evolution and habitability. One of the most fascinating aspects of Venus is the ongoing discussion about its geological activity. For a long time, scientists assumed that Venus, like Mars, was a geologically dead planet. However, recent studies suggest that Venus may still be geologically active today, with ongoing volcanic eruptions and tectonic movements reshaping its surface. Evidence for this comes from several sources. First, radar images from past missions like Magellan revealed that Venus's surface is dotted with volcanoes, lava flows, and other volcanic features. In fact, Venus has more volcanoes than any other planet in the solar system, with estimates ranging from hundreds to possibly over 1 million. However, it wasn't clear whether any of these volcanoes were still active. In 2020, a study using data from the European Space Agency's Venus Express mission provided new clues. Researchers found that certain lava flows on Venus's surface appeared to be relatively young, possibly less than a few million years old. This suggests that volcanic activity may have occurred on Venus in the geologically recent past, and perhaps even continues today. Additionally, the Venus Express mission detected localized hotspots of infrared radiation on the planet's surface, which could indicate active lava flows or volcanic eruptions. Further evidence of geological activity comes from Venus's mysterious surface deformations. The planet's surface is covered in large regions known as tesserae, areas of highly deformed terrain that appear to have been shaped by tectonic forces. These tesserae are some of the oldest features on Venus's surface, dating back hundreds of millions of years. But the fact that they are still visible suggests that Venus's surface has not undergone complete resurfacing by lava flows, as some earlier models had predicted. Venus's tectonic activity is still a subject of debate. Unlike Earth, Venus does not have plate tectonics. There are no large plates of crust that move around the surface. Instead, Venus's surface appears to behave more like a single, rigid shell that occasionally deforms and cracks under the pressure of the planet's internal heat. Some researchers believe that Venus may experience episodic bursts of tectonic and volcanic activity, where the planet's crust periodically releases built-up heat in dramatic events, followed by long periods of relative inactivity. Understanding Venus's geological processes is not just important for understanding the planet itself, it also has broader implications for planetary science. For example, studying Venus could help us understand the role that volcanism and tectonics play in regulating a planet's atmosphere. On Earth, volcanic eruptions release gases like carbon dioxide and water vapor into the atmosphere, which can affect the climate over long timescales. If Venus is still volcanically active, its eruptions could be contributing to the planet's thick, carbon dioxide-rich atmosphere and its runaway greenhouse effect. Venus also presents a puzzle when it comes to its magnetic field, or rather, its lack thereof. Earth's magnetic field is generated by the motion of molten iron in the planet's core, and it plays a crucial role in protecting our atmosphere from being stripped away by the solar wind. Venus, however, does not have a magnetic field, even though it is similar in size and composition to Earth. This raises the question of why Venus's core is not generating a magnetic field, and what role this has played in the planet's atmospheric evolution. One hypothesis is that Venus's core has cooled down to the point where it no longer has the convection currents needed to generate a magnetic field. Another possibility is that Venus's lack of plate tectonics has prevented the core from cooling efficiently, leading to a different kind of thermal evolution compared to Earth. Whatever the reason, The absence of a magnetic field on Venus has likely contributed to the loss of lighter gases like hydrogen and water from the planet's atmosphere, leaving behind the thick carbon dioxide atmosphere we see today. The absence of a magnetic field also makes Venus particularly vulnerable to the solar wind, a stream of charged particles emitted by the Sun. The solar wind can strip away particles from a planet's atmosphere, especially lighter elements like hydrogen. This process, known as atmospheric escape, may have played a key role in Venus's transformation from a potentially habitable world to the hellish planet it is today. By studying how the solar wind interacts with Venus's atmosphere, scientists hope to gain insights into the processes that shape planetary atmospheres more generally, including those of exoplanets orbiting other stars. Another enduring mystery of Venus is its superrotating atmosphere. While Venus's surface rotates very slowly, taking about 243 Earth days to complete one full rotation, its upper atmosphere whips around the planet at speeds of up to 360 km per hour, 224 miles per hour, completing a full circuit of the planet in just 4 Earth days. This phenomenon, known as superrotation, is not fully understood. Scientists are still trying to figure out what drives this extreme wind system and how it interacts with the planet's slow rotation. One hypothesis is that Venus's superrotating atmosphere is driven by a combination of solar heating and the planet's thick cloud cover. The Sun's energy heats the upper layers of the atmosphere, causing the air to rise and move from the planet's equator toward the poles. This circulation pattern could create strong winds that, over time, accelerate the entire atmosphere. However, the exact mechanisms behind Venus's superrotation are still unclear, and further study is needed to fully understand this unique feature of the planet's climate. Venus also has a unique weather system, characterized by high-speed winds, massive lightning storms, and strange cloud patterns. The planet's clouds are composed mainly of sulfuric acid, and they form dense, swirling patterns that can be observed from space. These clouds reflect much of the sunlight that hits Venus, giving the planet its bright, white appearance in the night sky. The cloud tops also experience lightning, although the exact frequency and strength of these lightning storms are still debated. One of the most intriguing features of Venus's weather system is its so-called polar vortices, giant, swirling storms located at the planet's poles. These vortices are unlike anything seen on Earth. They consist of multiple concentric rings of clouds that rotate around a central eye, similar to a hurricane. However, unlike hurricanes on Earth, which are driven by the Coriolis effect due to the planet's rotation, the polar vortices on Venus seem to be driven by the planet's complex atmospheric dynamics. These vortices can persist for long periods of time, changing shape and size as they rotate around the poles. Venus's weather system, while extreme, is not entirely dissimilar to weather patterns we see on other planets. For example, Jupiter and Saturn also have massive storms and polar vortices, although the mechanisms behind these storms are different. Studying Venus's weather system can help scientists understand the range of atmospheric phenomena that can occur on different planets, and how these phenomena are influenced by factors like atmospheric composition, solar energy, and planetary rotation. Despite the wealth of data collected by past missions, there is still much we don't know about Venus. For example, the exact composition of the planet's surface remains a mystery. Venus's thick atmosphere makes it difficult to observe the surface directly, and radar mapping can only provide limited information. Some researchers believe that the surface of Venus may be covered in large deposits of minerals that have been altered by the planet's extreme heat and pressure, but this has yet to be confirmed. Future missions to Venus will likely focus on addressing these unanswered questions. NASA's Da Vinci Plus mission, for example, aims to study the composition of Venus's atmosphere in detail, with the goal of understanding how the planet's climate evolved over time. The mission will send a probe into Venus's atmosphere, where it will measure the concentrations of various gases and search for signs of active volcanic eruptions. Additionally, the European Space Agency's Envision mission will use advanced radar to map Venus's surface in unprecedented detail, revealing the planet's geological history and helping to determine whether it is still geologically active. The mysteries of Venus reach far beyond its surface, atmosphere, and potential geological activity. One of the most enduring questions is related to Venus's past. What was this planet like billions of years ago? Was Venus always the fiery world it is today, or did it once resemble Earth, with oceans, rivers, and perhaps even life? This question has intrigued scientists for decades, as Venus's current conditions seem to suggest a drastic change in its environment at some point in its history. There are several clues that suggest Venus might have had a much more temperate past. One of the key pieces of evidence is the planet's size and composition, which are remarkably similar to Earth's. Both Venus and Earth are rocky planets of similar mass and diameter, which leads scientists to believe that they formed under similar conditions in the early solar system. This raises the possibility that Venus, like Earth, may have had a more Earth-like climate in its early history, with the potential for liquid water on its surface. In fact, some models of Venus's early climate suggest that the planet may have had oceans of water for as long as 2 to 3 billion years. This would have made Venus a potentially habitable world for a significant portion of its history, before the runaway greenhouse effect took hold and transformed it into the scorched world we see today. The question of how long Venus might have remained habitable, and whether it could have supported life during that time, is one of the biggest mysteries surrounding the planet. To explore this possibility, scientists have looked to the planet's atmosphere for clues. One of the key indicators of Venus's past climate is the ratio of hydrogen to deuterium in the planet's atmosphere. Deuterium is a heavier isotope of hydrogen, and because it is heavier, it tends to remain in a planet's atmosphere longer than regular hydrogen, which can escape into space more easily. By measuring the ratio of hydrogen to deuterium, scientists can estimate how much water Venus has lost over time. The Venus Express mission provided important data on this front, revealing that Venus has a much higher deuterium to hydrogen ratio than Earth, suggesting that the planet has lost a significant amount of water over its history. In fact, it is estimated that Venus may have lost as much as an Earth's ocean worth of water into space. This supports the idea that Venus once had large amounts of water on its surface, which could have formed oceans, rivers, and lakes in the planet's early days. But if Venus was once a water-rich world, what caused it to change so dramatically? The leading theory is that Venus experienced a runaway greenhouse effect, a process where the planet's atmosphere became so thick with greenhouse gases like carbon dioxide that it trapped more and more heat, causing the planet's temperature to rise uncontrollably. This may have started with volcanic activity releasing large amounts of carbon dioxide into the atmosphere, which in turn caused the planet to heat up, evaporating any surface water. As the water vapor itself is a powerful greenhouse gas, its presence in the atmosphere would have further amplified the heating effect, eventually leading to the extreme conditions we see on Venus today. Once Venus lost its water, it would have been impossible for the planet to reverse the runaway greenhouse effect. Water is a key component in regulating a planet's climate, as it helps to absorb carbon dioxide and store it in oceans and rocks through processes like weathering and plate tectonics. Without water, Venus had no way of removing carbon dioxide from its atmosphere, and the planet became locked in a state of extreme heat and pressure. The transformation of Venus from a potentially habitable world to a hellish one raises important questions about the future of other planets, including Earth. While Earth's climate is currently stable, the study of Venus serves as a reminder of how quickly a planet's environment can change under the right conditions. Understanding the factors that led to Venus's dramatic climate shift could help scientists better understand the risks of climate change on Earth, especially in terms of how rising carbon dioxide levels could affect our planet in the long term. Moreover, Venus provides an important case study for the search for life beyond Earth. The idea that Venus may have once been habitable, even for a relatively short period of time, suggests that other planets or moons in the solar system might also go through phases where they are capable of supporting life. This has important implications for the search for life on planets orbiting other stars. Many exoplanets discovered so far fall into the so-called Venus zone, a region where a planet is close enough to its star that it could experience a runaway greenhouse effect like Venus, but far enough away that it might retain some liquid water on its surface for a period of time. By studying Venus, we can learn more about the conditions that make a planet habitable and how quickly those conditions can change. But despite the evidence for Venus's potentially habitable past, there is still no direct proof that life ever existed on the planet. While Venus's early climate may have been favorable for life, it is not clear whether life could have taken hold there before the planet's climate became too extreme. One of the challenges in answering this question is the lack of direct data from Venus's surface. The extreme conditions on Venus make it difficult to send landers or rovers to explore the planet in detail. Previous missions that have attempted to land on Venus, such as the Soviet Venera missions, were only able to operate for a few hours before being destroyed by the intense heat and pressure. However, some scientists believe that if life did exist on Venus in the past, it might have left behind traces that could still be detectable today. For example, life on Earth has left a record of its existence in the form of fossilized microorganisms, organic molecules, and isotopic signatures in rocks. If similar signs of past life exist on Venus, they could be hidden beneath the planet's surface, waiting to be uncovered by future missions. Another intriguing possibility is that life might still exist on Venus today, albeit in a very different form than we would expect. In 2020, a team of scientists announced the detection of phosphine gas in Venus's atmosphere, a chemical that, on Earth, is typically associated with microbial life. The discovery of phosphine sparked a flurry of excitement and debate, as it raised the possibility that there could be life in the upper layers of Venus's atmosphere, where temperatures and pressures are much more temperate than on the planet's surface. However, the detection of phosphine on Venus remains controversial, and subsequent studies have called into question whether the gas is really present in the planet's atmosphere at all. Even if phosphine is present, it is not yet clear whether it is being produced by biological processes or by some unknown chemical or geological process. More research is needed to determine the true nature of this mysterious gas and what it might tell us about the potential for life on Venus. The idea that life could exist in Venus's clouds is certainly a fascinating one, but it also raises important questions about the limits of life as we know it. If life does exist in Venus's atmosphere, it would need to be able to survive in an environment that is extremely acidic and exposed to high levels of solar radiation. This would require life forms to have unique adaptations that are unlike anything we have seen on Earth. Studying such life, if it exists, could provide new insights into the diversity of life in the universe and expand our understanding of what conditions are necessary for life to thrive. As we delve deeper into the mysteries of Venus, we begin to uncover a wealth of information about its geology, atmospheric dynamics, and potential for habitability. One of the most striking features of Venus is its surface, which is dominated by volcanic plains, large volcanic structures, and vast highland regions. Unlike Earth, where plate tectonics plays a significant role in shaping the landscape, Venus appears to have a much more uniform surface, suggesting a different geological history. The presence of numerous volcanoes on Venus raises the question of whether the planet is still geologically active. Volcanism is a fundamental process that not only shapes a planet's surface but also plays a crucial role in regulating its atmosphere. Some of the largest volcanic features on Venus, such as Mont Mons and Sapos Mons, tower significantly above the surrounding plains, indicating that they are among the most massive volcanoes in the solar system. Additionally, the discovery of large lava flows and evidence of resurfacing events suggests that Venus may have undergone significant volcanic activity relatively recently in geological terms, potentially within the last few million years. The question of whether Venus is still volcanically active is particularly intriguing because it has implications for the planet's atmosphere and climate. Active volcanism could contribute to the continuous supply of carbon dioxide, which plays a central role in the greenhouse effect on Venus. If the planet were undergoing volcanic eruptions today, it could mean that the atmospheric conditions are still in flux, and understanding these processes could shed light on how Venus's climate has evolved over time. In recent years, researchers have proposed various mechanisms to explain the apparent geological activity on Venus. One hypothesis suggests that the planet may have a form of freeze-thaw tectonics, where the surface periodically cools and contracts, leading to cracking and the subsequent release of lava from the interior. This model diverges from the plate tectonics seen on Earth and implies that Venus has a more stagnant lid, meaning that while the surface may not be constantly shifting, it is still subject to significant internal pressures and heating. The potential for ongoing geological processes on Venus adds another layer of complexity to our understanding of the planet's atmosphere. The thick clouds of sulfuric acid in the atmosphere have long fascinated scientists, as they create an environment that is hostile to most forms of life we know. However, these clouds also present a unique opportunity to explore the chemistry of Venus's atmosphere in greater detail. For instance, studies have suggested that the clouds may contain microenvironments that could support extremophilic microorganisms, similar to those found in Earth's most inhospitable places, such as deep-sea hydrothermal vents and acid lakes. While the possibility of life in the clouds of Venus is an exciting prospect, it also raises questions about the adaptability of life in extreme conditions. The unique atmospheric chemistry of Venus, characterized by high levels of carbon dioxide and sulfuric acid, could provide insights into how life might evolve in environments very different from Earth. If microbial life exists in the clouds, it might use chemical processes that are unknown to us, potentially revolutionizing our understanding of the types of environments where life can thrive. As we consider the potential for life on Venus, we must also reflect on the implications of future exploration. Missions to Venus, such as NASA's upcoming Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, and Veritas, Venus Emissivity, Radio Science, in SAR, Topography, and Spectroscopy, missions, aim to study the planet's atmosphere and geology in greater detail. Da Vinci Plus will focus on understanding the composition of Venus's atmosphere and the potential for past water presence, while Veritas will map the surface and provide insight into the geological processes at play. These missions are crucial not only for unraveling the mysteries of Venus but also for addressing broader questions about planetary evolution and the potential for life elsewhere in the universe. By studying Venus, scientists can gain valuable knowledge about how rocky planets develop over time, how atmospheres change, and what factors contribute to the potential for habitability. This understanding is essential as we search for exoplanets and other star systems that may resemble Venus, Earth, or other planets within the solar system. One particularly intriguing aspect of Venus's exploration is the possibility of using innovative technologies to study the planet more effectively. For instance, balloon missions, which would allow researchers to explore the upper atmosphere of Venus at lower altitudes, could provide a wealth of data about the clouds and their chemical composition. Such missions would be significantly less impacted by the harsh conditions on the surface and could open new avenues for understanding the atmosphere and any potential life forms that might exist there. Furthermore, the study of Venus's geology can provide critical insights into the processes that shape terrestrial planets in general. For example, by comparing the geological features on Venus with those on Earth and Mars, scientists can begin to piece together a more comprehensive picture of how planetary bodies evolve and the role that geological processes play in maintaining or altering atmospheric conditions. The quest to understand Venus also serves as a reminder of the interconnectedness of our solar system. The conditions on Venus may hold valuable lessons for understanding climate change on Earth, particularly in the context of the greenhouse effect. As humanity grapples with the challenges of climate change, studying Venus's history of runaway greenhouse conditions may provide crucial insights into the long-term impacts of rising greenhouse gas levels and the importance of mitigating those effects before they lead to irreversible changes in our own atmosphere. In addition, exploring the mysteries of Venus fosters international collaboration in space exploration. Many countries, including Russia, the European Space Agency, and India, have expressed interest in sending missions to Venus. Collaborative efforts could lead to groundbreaking discoveries, shared data, and new technologies that enhance our understanding of planetary science as a whole. As we embark on this new era of exploration, it is essential to approach our studies of Venus with an open mind, recognizing that our perceptions of this enigmatic planet may change as we gather more information. Venus remains one of the most captivating and enigmatic planets in our solar system. Its harsh conditions, geological features, and atmospheric dynamics present a rich tapestry of mysteries waiting to be unraveled. As we continue to explore and study Venus, we open the door to new discoveries that could redefine our understanding of what it means for a planet to be habitable, and what life might look like in environments that seem inhospitable by earthly standards. Moreover, the exploration of Venus is not just about the planet itself, it is about understanding our place in the cosmos. The study of other worlds can illuminate the processes that govern our own planet and inspire future generations to reach for the stars. With each mission, we draw closer to understanding the complex interplay of forces that shape our solar system, while also searching for answers to fundamental questions about life, existence, and the potential for discovery beyond our home planet. As we gaze at the night sky, Venus shines brightly, often referred to as the evening star, or the morning star. This visibility has captured the imagination of countless generations throughout history. Ancient civilizations worshipped it, poets wrote about it, and modern astronomers study it with advanced technology. Each observation of this planet brings us closer to answering questions that have persisted for centuries. With continued advancements in technology and exploration, we may soon unlock the secrets of Venus. Who knows what revelations lie ahead? Perhaps one day we will send robotic explorers that can withstand the planet's extreme conditions for longer periods, enabling us to gather unprecedented data. As we work to understand this mysterious neighbor, we inch closer to answering questions about the potential for life beyond Earth and the myriad forms it might take. As we further unravel the intricacies of Venus, it becomes clear that our understanding of the planet is still evolving, with each mission and study adding new dimensions to its narrative. The exploration of Venus not only holds implications for our understanding of its environment, but also serves as a critical benchmark for comparative planetology, allowing us to explore the differences and similarities among terrestrial planets. One of the most profound aspects of Venus's atmosphere is the greenhouse effect, which is not only extreme but also offers a fascinating case study in planetary climate dynamics. The surface temperature of Venus averages around 467 degrees Celsius, 872 degrees Fahrenheit, making it the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. This intense heat is primarily due to the thick atmosphere composed of about 96.5% carbon dioxide, with clouds of sulfuric acid that reflect sunlight but trap heat, creating a runaway greenhouse effect. The study of this phenomenon on Venus provides crucial insights into the greenhouse effect on Earth. It serves as a stark warning of what could happen if greenhouse gas concentrations rise uncontrollably. By analyzing the processes that led to Venus's inhospitable climate, scientists can better understand the importance of maintaining a balance in Earth's atmospheric composition. This comparison not only highlights the fragility of planetary environments, but also emphasizes the need for responsible stewardship of our own planet. The chemical processes occurring in Venus's atmosphere are incredibly complex and merit further investigation. For example, the presence of phosphine, a gas that on Earth is associated with biological processes, has sparked significant debate among scientists regarding its implications for potential life. While phosphine has been detected in trace amounts in Venus's atmosphere, the exact processes that produce it remain unclear. Its presence raises intriguing questions about the possible existence of unknown biological or geological processes on Venus, suggesting that the planet may still hold secrets that challenge our current understanding of life's potential. Furthermore, the clouds of Venus provide a unique opportunity for scientific study. These clouds are not merely a hostile environment but may also harbor complex chemical interactions. Some researchers speculate that the clouds could serve as a habitat for microbial life, thriving in the sulfuric acid droplets. This idea opens up exciting avenues for exploration and highlights the potential for discovering life forms that have adapted to extreme conditions. The ongoing research into Venus's clouds emphasizes the importance of looking beyond traditional definitions of habitability, considering how life might exist in environments vastly different from those on Earth. The investigation of Venus also compels us to consider the historical context of planetary exploration. The Soviet Union's Venera program in the 1960s and 1970s yielded valuable data, including the first images of the surface of Venus. These early missions faced numerous challenges, including the need to withstand extreme pressure and heat. Venera probes, such as Venera 7, were groundbreaking achievements that laid the foundation for future missions. Today, we stand on the shoulders of these pioneers as we develop advanced technologies that allow us to explore Venus in ways that were previously unimaginable. As we prepare for upcoming missions, the role of international collaboration in space exploration becomes increasingly evident. NASA's Da Vinci Plus and Veritas missions are not isolated endeavors. They represent a concerted effort among various space agencies to deepen our understanding of Venus. The European Space Agency's Envision mission, set to launch in the 2030s, will complement these efforts by studying the geological history and atmosphere of Venus. This collaborative spirit highlights the global commitment to exploring our solar system and seeking answers to fundamental questions about our place in the universe. In this context, the study of Venus serves as a microcosm of broader themes in planetary science and exploration. It encourages us to consider the interconnectedness of planetary processes, the potential for life in unexpected places, and the implications of our discoveries for understanding Earth and other celestial bodies. As we pursue these inquiries, we are reminded of the humility and curiosity that drive scientific exploration. The societal and cultural implications of our discoveries about Venus are also noteworthy. The notion of life on another planet has captivated the public imagination for centuries, inspiring literature, art, and cinema. The prospect of finding microbial life in the clouds of Venus could reignite interest in space exploration and highlight the importance of scientific inquiry in addressing existential questions. As we learn more about Venus, we may also find ourselves re-examining our relationship with our planet and the broader cosmos. Moreover, the exploration of Venus encourages interdisciplinary collaboration, bringing together experts from fields such as geology, atmospheric science, astrobiology, and engineering. This collaborative approach fosters innovative thinking and allows us to tackle complex questions about planetary evolution and habitability from multiple perspectives. The exchange of ideas and expertise enriches our understanding and drives the scientific community forward. As we gaze upon Venus, the evening star, we are reminded of the beauty and complexity of our universe. The shimmering light that graces our skies serves as a beacon of mystery, urging us to explore further. The pursuit of knowledge about Venus not only enriches our understanding of the planet but also deepens our appreciation for the interconnectedness of all celestial bodies. As we continue to investigate the mysteries of this enigmatic planet, we embark on a journey that may one day reveal answers to questions we have yet to ask. In addition to its atmospheric and geological features, Venus holds a unique place in the narrative of human exploration. Its visibility in the night sky has led to countless interpretations and cultures, making it one of the most recognizable celestial bodies. The historical significance of Venus extends beyond astronomy. It also reflects the evolution of human understanding of our place in the universe. The transition from viewing Venus as a mystical object to studying it through scientific inquiry exemplifies humanity's journey toward enlightenment. Each advancement in our understanding of Venus has paved the way for future discoveries, illuminating the path for generations to come. As we look to the future of Venus exploration, we can anticipate new technologies that will enhance our ability to study the planet. The development of advanced robotic missions, capable of navigating the harsh conditions of Venus's surface, could provide invaluable data and insights. Imagine a future where we deploy landers that can operate for extended periods, gathering information on the geology, atmosphere, and potential habitability of Venus. The integration of artificial intelligence and machine learning into planetary exploration is another exciting avenue that may transform how we study Venus. These technologies can analyze vast amounts of data from multiple sources, identify patterns, and generate hypotheses that may not be immediately apparent to human researchers. By harnessing the power of AI, we can enhance our ability to uncover the secrets of Venus and other planets in our solar system. Additionally, the exploration of Venus may have implications for understanding exoplanets, planets orbiting stars beyond our solar system. As we identify and study exoplanets that share characteristics with Venus, we can gain insights into the processes that shape planetary atmospheres and potential habitability. This comparative approach allows us to expand our understanding of the diversity of planetary environments and the conditions that may support life elsewhere in the universe. As we delve deeper into the enigma of Venus, it is essential to consider not only the scientific aspects, but also the technological advancements that have facilitated our understanding of this neighboring planet. The evolution of space technology has significantly influenced our exploration strategies, allowing us to gather data and analyze conditions that were previously thought to be unattainable. For instance, the development of remote sensing technologies has been pivotal in our ability to study Venus from afar. Radar imaging, particularly from missions like NASA's Magellan in the early 1990s, has allowed scientists to map approximately 98% of Venus's surface with remarkable precision. This high-resolution imaging revealed extensive volcanic plains, vast highland regions, and evidence of tectonic activity, suggesting a dynamic geological history that continues to unfold. These discoveries have led to a paradigm shift in our understanding of Venus. Once viewed as a stagnant, unchanging world, it is now considered a planet with a complex and active geology. The presence of features such as coronae, large, circular structures that may have formed due to upwelling magma, points to a history of volcanic activity that is not only recent but potentially ongoing. This raises compelling questions about the processes that govern Venus's geology, and whether it has experienced major resurfacing events in its history. In addition to geological insights, studying the surface of Venus can provide crucial information about its atmosphere. The planet's harsh surface conditions, extreme temperatures and crushing pressures, present significant challenges for landers. However, advancements in materials science and engineering are paving the way for more resilient spacecraft capable of withstanding these conditions. Future missions could employ new technologies, such as heat-resistant materials and advanced cooling systems, to enable prolonged surface exploration. The idea of sending a mission to Venus's surface raises profound implications for astrobiology. If we can confirm that Venus was once more Earth-like, with conditions that could support life, we may gain insights into the potential for life on other planets. The transition from a habitable environment to a harsh, inhospitable landscape raises important questions about planetary evolution and the factors that contribute to the habitability of worlds beyond our own. Moreover, the exploration of Venus offers valuable lessons for understanding climate change on Earth. The extreme greenhouse effect that has transformed Venus into a scorching inferno serves as a cautionary tale for our own planet. As we grapple with rising temperatures and environmental degradation, the study of Venus underscores the importance of maintaining a balanced atmosphere. The insights gleaned from Venusian research can inform our understanding of climate dynamics, helping us to develop strategies for mitigating climate change and preserving Earth's fragile ecosystems. As we consider the future of Venus exploration, we must also reflect on the role of public engagement and education. The exploration of outer space has a unique ability to inspire curiosity and foster a sense of wonder about the universe. Engaging the public in discussions about Venus and the broader implications of space exploration can ignite interest in science and technology, encouraging the next generation of scientists, engineers, and explorers. Initiatives such as citizen science projects, educational outreach programs, and public lectures can bridge the gap between scientific communities and the general public. By sharing the excitement of discovery and the relevance of space research to everyday life, we can cultivate a culture of curiosity and innovation that extends beyond the confines of academia. This grassroots engagement is crucial for securing funding and support for future missions, ensuring that the exploration of Venus remains a priority in the years to come. Additionally, the concept of international collaboration in space exploration cannot be overstated. As we face the complexities of exploring other planets, partnerships among space agencies around the world are becoming increasingly vital. The shared resources, expertise, and technological capabilities that emerge from these collaborations can enhance our capacity to conduct meaningful research on Venus. For example, the upcoming Da Vinci Plus mission by NASA aims to investigate the composition of Venus's atmosphere and its geological history, while ESA's Envision mission will complement these efforts by examining the planet's surface and geological features. Such synergistic endeavors can yield richer data and insights, propelling our understanding of Venus and its processes forward. Looking ahead, we can anticipate a renewed interest in Venus as scientists and engineers continue to develop innovative mission concepts. Proposals for aerial missions, such as flying drones or balloons, could allow us to explore the dense atmosphere of Venus in ways that traditional landers cannot. These platforms could collect atmospheric data, study cloud chemistry, and even search for signs of life in the upper atmosphere, where conditions are less extreme than the surface. The use of robotics in space exploration is not limited to landers or aerial vehicles. It also extends to orbiters that can conduct long-term monitoring of Venus. Continuous observations can reveal changes in the atmosphere and surface, helping to paint a comprehensive picture of the planet's evolution over time. This kind of data is invaluable for understanding not only Venus but also the dynamics of other planets within our solar system and beyond. As we embark on this journey to explore the mysteries of Venus, we must remain cognizant of the ethical considerations that accompany planetary exploration. As we seek to understand Venus and its processes, we must also consider the potential impact of our missions on the planet itself. While Venus is often viewed as a harsh and lifeless world, it is essential to approach its exploration with a sense of stewardship, recognizing that our actions may have consequences for the celestial bodies we investigate. This ethical perspective extends to discussions about planetary protection and the prevention of contamination. Ensuring that our missions do not inadvertently introduce Earth-based organisms to Venus is critical to preserving the integrity of scientific research. By prioritizing planetary protection measures, we can uphold the principles of responsible exploration and maintain the scientific value of our findings. In addition to the scientific and ethical dimensions of Venus exploration, we must also embrace the philosophical implications of our discoveries. The exploration of Venus compels us to reflect on our place in the universe and the nature of life itself. As we uncover the complexities of this neighboring planet, we are prompted to consider the possibilities of life beyond Earth and the conditions that may support it. The quest to understand Venus ultimately leads us to contemplate the broader questions of existence, evolution, and the potential for intelligence elsewhere in the universe. As we continue to probe the depths of space and explore distant worlds, we are reminded that we are not only uncovering the mysteries of our solar system but also expanding our understanding of life and consciousness itself. As we further explore the enigma of Venus, it becomes evident that this planet is not merely a subject of scientific interest. It also serves as a poignant reminder of the intricate balance that sustains planetary environments. The stark contrast between Venus and Earth illuminates the delicate nature of climate systems, urging us to reflect on the fragility of our own planet. Understanding the factors that contributed to Venus's transformation into a hellish world can provide crucial insights into the potential consequences of climate change on Earth. One of the most striking aspects of Venus's climate is the overwhelming dominance of carbon dioxide in its atmosphere, which constitutes about 96.5% of its composition. This high concentration leads to an intense greenhouse effect, where solar radiation is trapped, resulting in surface temperatures that can soar to around 900 degrees Fahrenheit, 475 degrees Celsius. Such conditions render Venus a unique case study in the effects of greenhouse gases on planetary climates, highlighting the dangers of excessive carbon emissions. The atmospheric pressure on Venus is another critical factor contributing to its hostile environment. At the surface, the pressure is approximately 92 times that of Earth's atmosphere, equivalent to being nearly a mile underwater. This crushing pressure presents formidable challenges for landers and rovers, making prolonged exploration on the surface exceedingly difficult. As scientists design future missions, they must consider not only the temperature extremes but also the relentless pressure that would need to be withstood by any instruments sent to this planet. The dynamics of Venus's atmosphere are further complicated by its unique wind patterns. The upper atmosphere experiences superrotational winds that can reach speeds of up to 200 miles per hour, 322 kilometers per hour, circulating the planet approximately every 4 Earth days, while the surface takes about 243 Earth days to complete a rotation. This dissonance in rotation creates a complex and chaotic climate system that remains a subject of ongoing research. Understanding the behavior of these winds could offer insights into the atmospheric processes at work on other planets, enhancing our knowledge of exoplanets that exhibit similar conditions. The possibility of past water on Venus adds yet another layer to its narrative. Geologic evidence suggests that Venus may have had liquid water on its surface for a significant period in its early history. Such conditions could have supported microbial life, raising the tantalizing question of whether life once existed on Venus. The search for signs of past habitability fuels ongoing interest in the planet, as scientists strive to determine the factors that led to the drastic transformation of its environment. One of the more controversial hypotheses is that Venus may still harbor microbial life in its upper atmosphere. Some researchers posit that, while the surface conditions are inhospitable, the cloud layers at altitudes between 30 to 40 kilometers could possess temperatures and pressures more akin to those found on Earth. This notion was recently reignited by the controversial detection of phosphine in the Venusian atmosphere, a potential biosignature that, if confirmed, would significantly alter our understanding of life's possibilities in the cosmos. However, the debate surrounding this discovery highlights the need for rigorous verification and further investigation to draw definitive conclusions about the nature of Venus's atmosphere. As we contemplate the implications of these findings, it is essential to consider the role of interdisciplinary collaboration in advancing our understanding of Venus. The intersection of astrobiology, geology, and climate science creates a rich tapestry of research opportunities, encouraging scientists to share insights and methodologies across fields. This collaborative approach not only enhances the rigor of scientific inquiry but also fosters a holistic understanding of the complex processes that shape planetary environments. In an era where space exploration is increasingly collaborative, the importance of sharing data and resources cannot be overstated. The exchange of knowledge between international space agencies and research institutions can lead to innovative solutions for the challenges posed by exploring harsh planetary environments. For instance, collaborative missions could leverage advancements in artificial intelligence and machine learning to analyze vast datasets, identify patterns, and develop predictive models for understanding planetary atmospheres. Looking ahead, the integration of new technologies will play a pivotal role in the future of Venus exploration. Advancements in materials science, robotics, and data analysis are poised to revolutionize our approach to studying this enigmatic planet. The development of high-temperature electronics and miniaturized sensors could enable the deployment of innovative landers capable of surviving on the Venusian surface for extended periods. These new instruments could provide invaluable data on surface composition, geological activity, and atmospheric dynamics. Additionally, as we strive to understand the origins and evolution of planetary systems, Venus serves as a key comparison point to the myriad of exoplanets being discovered in the habitable zones of other stars. The lessons learned from Venus's transformation, along with the insights gained from its geological and atmospheric features, can inform our understanding of how other planets might evolve under different conditions. This knowledge is essential as we expand our search for potentially habitable worlds beyond our solar system. As we delve even deeper into the mysteries of Venus, it's crucial to examine the planet's geological features and the implications they hold for understanding its past. Venus is often described as Earth's twin due to its similar size and composition. However, the differences in their geological histories tell a compelling story about the forces that shape planetary environments. The surface of Venus is primarily composed of volcanic plains, with numerous volcanoes and vast lava flows. Many scientists believe that Venus is geologically active, with ongoing volcanic processes potentially reshaping its landscape even today. This is a stark contrast to Earth, where plate tectonics drive geological activity. The lack of tectonic plates on Venus raises intriguing questions about how its surface has evolved over time. Venus is dotted with large shield volcanoes, such as Mont Mons and Sif Mons, which resemble the shield volcanoes found in Hawaii. These formations suggest a history of extensive volcanic activity. Interestingly, some researchers have proposed that certain features on Venus, known as coronae, are the result of volcanic processes that create concentric rings of elevation around a central depression. These structures are unique to Venus and provide insight into its geological evolution. One of the most exciting aspects of Venusian geology is the potential for ancient river systems and the presence of minerals that suggest the past existence of water. Radar mapping of the planet has revealed what appear to be features resembling dry riverbeds, indicating that liquid water may have flowed across the surface in the distant past. The presence of minerals such as clays and sulfates further supports the idea that water played a significant role in Venus's history. The discovery of such geological features has profound implications for understanding the conditions that prevailed on Venus billions of years ago. Scientists speculate that if Venus had a more temperate climate with liquid water, it could have supported microbial life. This idea continues to fuel research into Venus's potential habitability and the search for biosignatures in its atmosphere. Furthermore, the study of Venusian geology provides a unique opportunity to compare and contrast with Earth's geological processes. The differences between the two planets highlight the various factors that influence planetary development, including atmospheric composition, solar radiation, and geological activity. Understanding these differences can enhance our comprehension of planetary evolution throughout the solar system and beyond. In recent years, interest in Venus has surged, leading to renewed efforts for exploration. NASA's mission to Venus, known as Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, aims to analyze the atmosphere's composition and investigate its potential for past habitability. Another mission, Veritas, Venus Emissivity, Radio Science, in SAR, Topography, and Spectroscopy, will map the surface and analyze its geological history. These missions represent a critical step toward unraveling the complexities of Venus's atmosphere and geology. As we prepare for these missions, the technological innovations that will be employed are noteworthy. Advanced imaging techniques, spectrometry, and remote sensing capabilities will provide a wealth of data about the atmosphere and surface of Venus. The findings from these missions are expected to enhance our understanding of the processes that shape not only Venus but also exoplanets with similar characteristics. The quest to understand Venus also touches on philosophical and existential questions. As we ponder the nature of life and the conditions necessary for its existence, Venus serves as a reminder of the delicate balance required to sustain life. The stark reality of Venus's transformation from a potentially habitable planet to a hellish environment raises questions about the future of Earth and the importance of protecting our own environment. This awareness prompts a broader dialogue about the responsibility humanity bears in its stewardship of Earth. The consequences of climate change, driven by human activity, serve as a cautionary tale. As we uncover the secrets of Venus, we must also reflect on our choices and their impact on our planet. This dual exploration of Venus and Earth underscores the interconnectedness of all planetary environments. Moreover, the fascination with Venus extends beyond the realm of science. It inspires art, literature, and cultural reflection. Throughout history, Venus has been associated with various deities and symbols of love, beauty, and femininity. These cultural interpretations enrich our understanding of how humanity perceives the cosmos and its place within it. As we continue to explore the mysteries of Venus, the interplay between science and culture becomes increasingly relevant. The stories we tell about Venus can shape public perception and inspire future generations to engage with science and exploration. By fostering curiosity and a sense of wonder, we can encourage a new generation of scientists, engineers, and artists to contribute to the ongoing narrative of exploration. Looking forward, the implications of our discoveries on Venus extend beyond our solar system. As we identify the characteristics of our neighboring planets, we gain insight into the potential for life in other star systems. The search for exoplanets that resemble Venus or Earth is an integral part of modern astronomy. With advanced telescopes and detection methods, astronomers can identify planets in the habitable zones of distant stars, examining their atmospheres and conditions for potential habitability. The study of Venus, therefore, is not an isolated endeavor. It is part of a larger quest to understand the diversity of planetary environments across the universe. As we seek to uncover the mysteries of our neighboring planets, we also gain a greater appreciation for the uniqueness of Earth. This dual focus, on Venus and the search for life beyond our solar system, encourages a holistic approach to understanding our place in the cosmos. As we explore the multifaceted nature of Venus further, we must turn our attention to its atmosphere, one of the most intriguing aspects of the planet. The dense atmosphere of Venus is composed primarily of carbon dioxide, making up about 96.5% of its atmospheric composition, with nitrogen constituting about 3.5%. This thick carbon dioxide layer creates an extreme greenhouse effect, resulting in surface temperatures averaging around 467 degrees Celsius, 872 degrees Fahrenheit. These temperatures are hot enough to melt lead, rendering the planet uninhabitable for known life forms. The atmospheric pressure on Venus is also a staggering 92 times that of Earth's at sea level, equivalent to being nearly a kilometer underwater on our planet. This immense pressure, combined with the scorching temperatures, creates a hellish environment that has led many to label Venus as Earth's evil twin. However, it is essential to recognize that this thick atmosphere is not just a barrier. It holds clues to the planet's geological history and its potential for past life. One of the most significant discoveries regarding Venus's atmosphere is the presence of clouds made of sulfuric acid. These clouds create a reflective layer that contributes to the planet's bright appearance when viewed from Earth. They also play a crucial role in the planet's atmospheric dynamics, influencing wind patterns and temperature distributions. The clouds, while hostile, could potentially serve as a medium for microbial life. Some scientists speculate that microorganisms may exist in the upper atmosphere of Venus, where temperatures are less extreme and could provide a more hospitable environment. Recent studies have focused on detecting phosphine in the atmosphere of Venus, a chemical associated with biological processes on Earth. The detection of phosphine sparked a wave of excitement in the scientific community, as it raised the tantalizing possibility of life in the clouds of Venus. Although subsequent analyses have cast doubt on the initial findings, the discussion it generated has prompted renewed interest in Venusian exploration and research. This prospect of microbial life in Venus's atmosphere invites us to consider the broader implications of our search for extraterrestrial life. The focus has often been on planets within the Goldilocks zone, regions around stars where conditions are just right for liquid water to exist. However, the idea that life could exist in extreme environments, such as the clouds of Venus, expands the criteria for habitability. This understanding encourages scientists to rethink how and where we search for life in the universe. The potential for life, even in the harshest environments, has profound implications for our understanding of life's resilience and adaptability. The study of extremophiles on Earth, organisms that thrive in extreme conditions, provides valuable insights into the possibilities for life on other planets. If life can exist in the clouds of Venus, it prompts questions about the diversity of life forms and their ability to adapt to seemingly inhospitable environments. Exploration of Venus's atmosphere and the search for signs of life are further complicated by the planet's harsh conditions. Any mission to study the atmosphere directly must contend with extreme temperatures and pressures. Historically, several spacecraft have been sent to Venus, including the Soviet Venera missions, which successfully landed on the surface and transmitted data back to Earth. However, the harsh conditions limited the lifespan of these missions to just a few hours. To overcome these challenges, future missions to Venus are likely to focus on aerial platforms and long-duration balloons. These innovative designs would allow for the collection of atmospheric data over extended periods, providing valuable insights into the composition and dynamics of the atmosphere. NASA's proposed mission, Venus Life Finder, aims to deploy a balloon to float through the atmosphere, analyzing the chemical composition for signs of life. In addition to the search for life, studying Venus's atmosphere has broader implications for understanding climate processes on Earth. The greenhouse effect on Venus serves as a stark warning about the potential consequences of unchecked climate change. By examining how Venus evolved into a hellish environment, scientists can gain insights into the delicate balance that sustains Earth's climate. This comparison also emphasizes the importance of understanding the interactions between a planet's atmosphere, geology, and potential for life. As we grapple with climate challenges on Earth, learning from Venus can guide our efforts to mitigate the effects of global warming and preserve our planet's delicate ecosystem. Moreover, studying Venus serves as a reminder of the interconnectedness of planetary systems within our solar system. The study of one planet often yields insights applicable to others, including exoplanets. As our capabilities to detect and analyze distant worlds improve, the lessons learned from Venus can inform our understanding of planetary formation, evolution, and the potential for life across the universe. As we continue to probe the mysteries of Venus, we also find ourselves confronting philosophical questions about our place in the cosmos. The exploration of this enigmatic planet stirs our imagination and compels us to reflect on the nature of existence. What does it mean to seek life beyond Earth? How do our discoveries shape our understanding of life and our role as stewards of our planet? The scientific journey to uncover the secrets of Venus also serves as an invitation to contemplate the future of space exploration. As we invest in missions to explore the atmospheres of Venus and other planets, we must consider how these endeavors can inspire public interest and engagement in science. The mysteries of Venus have captivated imaginations for centuries, and our modern explorations hold the potential to ignite a new wave of curiosity about our place in the universe. As we look to the future, we must also recognize the importance of international collaboration in space exploration. The study of Venus is not limited to any single nation. It is a global endeavor that requires shared resources, knowledge, and expertise. Collaborative missions can maximize the impact of our scientific endeavors and foster a sense of unity in the pursuit of knowledge. As our exploration of Venus continues, we must also delve deeper into its geological characteristics, which hold many clues about the planet's history and potential for life. Venus's surface is primarily composed of volcanic plains, with large volcanic structures such as shield volcanoes and extensive lava flows. This volcanic activity suggests that Venus may still be geologically active, a possibility that has significant implications for understanding its evolution and atmospheric dynamics. One of the most prominent features on Venus is the large volcanic plateau known as Ishtartera. This region is about the size of Texas and is characterized by extensive volcanic activity, which indicates that the planet has undergone significant geological changes throughout its history. Scientists believe that the surface of Venus has been reshaped by volcanic eruptions and tectonic activity, resulting in a relatively young surface, geologically speaking, estimated to be around 300 to 500 million years old. Additionally, the presence of unique geological formations, such as large coronae, adds to the intrigue of Venus. These circular features, which can be hundreds of kilometers wide, are believed to be the result of upwelling magma from the planet's interior. The study of coronae provides insight into the tectonic processes that shape Venus's surface and highlights the potential for ongoing geological activity. Understanding these processes can shed light on the planet's thermal evolution and its capacity to support any form of life. The geological processes at play on Venus also raise questions about its past climate and the potential for habitable conditions. Evidence suggests that Venus may have once possessed oceans of liquid water, akin to Earth's. However, a runaway greenhouse effect transformed this once warm and potentially habitable planet into a scorching desert. This drastic shift in climate serves as a cautionary tale about the fragility of planetary environments and underscores the need for careful stewardship of our own planet. Moreover, the question of whether Venus had life in the past continues to inspire scientific inquiry. If Venus did have oceans, could microbial life have existed in its depths? While the current conditions are inhospitable, understanding the planet's history might provide insights into how life can arise and evolve in diverse environments. The study of Venus's geological history also has implications for understanding exoplanets, particularly those in similar environments. As astronomers discover more Earth-like planets in the habitable zones of distant stars, the geological history of Venus serves as a valuable comparison point. By examining how different planetary systems evolve, we can refine our search criteria for planets that may harbor life. In addition to the surface features, Venus is home to a range of unusual phenomena, including its retrograde rotation. Unlike most planets in our solar system, Venus rotates on its axis in the opposite direction, resulting in its sun rising in the west and setting in the east. This retrograde rotation raises questions about the planet's formation and the forces that may have influenced its evolution. The length of a day on Venus is also longer than its year. One rotation takes approximately 243 Earth days, while it takes about 225 Earth days to orbit the Sun. This unusual relationship between its rotation and revolution creates a unique dynamic in terms of temperature distribution and atmospheric circulation. The slow rotation, combined with the dense atmosphere, leads to extreme winds in the upper layers of the atmosphere, which can reach speeds of up to 360 km per hour, 224 miles per hour. These high-speed winds contribute to the planet's unique weather patterns and add to the complexity of its atmospheric dynamics. The interplay between the slow rotation and the fast-moving atmosphere presents a fascinating area of research, as scientists work to understand how these forces shape the planet's climate and weather systems. In recent years, advancements in technology and space exploration have allowed scientists to gather more detailed information about Venus. The European Space Agency's Venus Express mission, which operated from 2006 to 2014, provided invaluable data on the planet's atmosphere, surface, and geological features. The mission revealed insights into the presence of lightning in Venus's atmosphere, suggesting active weather systems and further highlighting the planet's complexity. Additionally, NASA's Magellan spacecraft, which mapped the surface of Venus using radar imaging, has greatly enhanced our understanding of the planet's geology. These missions have not only deepened our knowledge of Venus but have also laid the groundwork for future explorations and studies. Looking ahead, the next wave of missions to Venus promises to uncover even more mysteries. NASA's upcoming missions, such as the Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, and Veritas, Venus Emissivity, Radio Science, in SAR, topography, and spectroscopy, missions aim to study the atmosphere and surface of Venus in greater detail. Da Vinci Plus will focus on understanding the composition and dynamics of the atmosphere, while Veritas will map the planet's surface and analyze its geological history. These missions are poised to answer critical questions about Venus's atmosphere, geology, and potential for life, while also providing valuable comparisons to Earth. As we seek to understand our neighboring planet, we are reminded of the interconnectedness of planetary systems and the importance of continued exploration. The mysteries of Venus offer a window into the complex processes that govern planetary environments and the potential for life beyond Earth. As we continue to explore this enigmatic world, we unravel not only the secrets of Venus but also our understanding of planetary evolution, climate dynamics, and the conditions necessary for life. The journey to uncover the mysteries of Venus is a testament to human curiosity and our relentless pursuit of knowledge. Each discovery brings us closer to understanding the forces that shape our universe and our place within it. As we continue to probe the depths of the cosmos, let us remain open to the possibilities that await us, for the mysteries of Venus are just the beginning of a much larger quest for understanding. As we explore this intriguing planet, we are reminded that the search for life is not just a scientific endeavor, it is a fundamental part of what it means to be human. The desire to understand our universe and our role within it drives us to push the boundaries of exploration and inquiry. The stories of Venus are woven into the fabric of our understanding of the cosmos, challenging us to think critically about the nature of existence and our place in the universe. As we peer into the depths of space and seek answers to our questions, we honor the legacy of exploration and inquiry that has defined humanity for centuries. The lessons learned from the exploration of Venus will undoubtedly shape our future endeavors, guiding our understanding of the cosmos and our responsibilities as stewards of our own planet. The mysteries of Venus invite us to embrace the unknown and continue our quest for knowledge, knowing that each step we take leads us closer to understanding the universe and our place within it. The exploration of Venus is more than just a scientific endeavor. It is an invitation to reflect on our journey as a species, to ponder the nature of life, and to appreciate the beauty and complexity of the universe we inhabit. As we strive to unlock the secrets of this enigmatic planet, we also embark on a journey of self-discovery, exploring the very essence of what it means to be alive in this vast cosmos. The future of Venus exploration is bright, with numerous missions on the horizon that promise to unveil new insights and deepen our understanding of this captivating world. As we anticipate these discoveries, we are reminded of the interconnectedness of our solar system and the potential for life beyond our Earth. The mysteries of Venus will continue to inspire generations to come, fueling the flames of curiosity and discovery that define humanity's quest for knowledge. In this ongoing journey, we are reminded that the exploration of space is not merely about reaching new frontiers. It is about fostering a spirit of wonder, curiosity, and collaboration that transcends borders and unites us in our shared quest for understanding. The mysteries of Venus are a testament to our innate desire to explore, learn, and connect with the universe around us, and as we continue this exploration, we are reminded that the journey is just as important as the destination. As our journey through the mysteries of Venus unfolds, it is essential to consider the implications of these discoveries for our understanding of other celestial bodies, particularly in the search for extraterrestrial life. The exploration of Venus has profound implications for astrobiology, offering a unique perspective on the potential for life in extreme environments. The harsh conditions on Venus, characterized by high temperatures and pressure, challenge our preconceptions about where life can exist. While we often think of life as requiring specific conditions, such as liquid water and a temperate climate, Venus serves as a reminder that life may adapt to survive in environments previously thought to be inhospitable. Extremophiles on Earth, organisms that thrive in extreme conditions such as high acidity, pressure, or temperature, give us a glimpse into the potential for life in similar environments elsewhere in the universe. Recent studies have sparked discussions about the possibility of microbial life in the upper atmosphere of Venus, where temperatures and pressures are more Earth-like. In 2020, researchers detected the presence of phosphine, a chemical associated with biological processes, in the Venusian atmosphere. While subsequent analyses have raised questions about the reliability of these findings, they underscore the importance of continued exploration and investigation. The presence of phosphine, if confirmed, would suggest that some form of life could exist in the clouds of Venus, challenging our understanding of life's potential distribution in the universe. The search for life on Venus parallels efforts to explore other celestial bodies in our solar system, particularly Mars and the icy moons of Jupiter and Saturn, such as Europa and Enceladus. These environments, characterized by subsurface oceans and potential hydrothermal activity, offer promising locations for the search for extraterrestrial life. The study of Venus not only enhances our understanding of planetary evolution and atmospheric dynamics, but also provides a comparative framework for assessing the habitability of other worlds. The future of Venus exploration also extends beyond our solar system. As astronomers continue to discover exoplanets and habitable zones around distant stars, the insights gained from Venus will inform our understanding of their atmospheres and potential for life. The lessons learned from studying Venus's atmosphere, climate, and geological history may help scientists refine their models for identifying exoplanets that could support life. As we reflect on the knowledge we have gained from Venus, we must also acknowledge the technological advancements that have made these discoveries possible. The development of space exploration technology, from powerful telescopes to sophisticated spacecraft, has revolutionized our ability to study distant worlds. These innovations not only enhance our understanding of Venus but also pave the way for future explorations of the cosmos. The exploration of Venus is a testament to the collaborative efforts of scientists, engineers, and researchers from around the world. The pursuit of knowledge transcends national borders and unites humanity in our quest to understand the universe. As we continue to explore Venus, we celebrate the spirit of collaboration that defines our efforts to uncover the mysteries of the cosmos. In addition to the scientific advancements, the exploration of Venus has captured the imagination of artists, writers, and thinkers throughout history. The enigmatic qualities of Venus have inspired countless works of literature, art, and philosophy, reflecting our fascination with the unknown. As we seek to understand the planet, we also engage with its cultural significance, reminding us that the exploration of space is not only a scientific endeavor but also a deeply human pursuit. The legacy of Venus exploration will undoubtedly shape our understanding of our place in the universe. Each mission, each discovery, brings us closer to understanding the forces that govern planetary environments and the potential for life beyond Earth. As we stand on the threshold of new discoveries, we are reminded of the interconnectedness of all things and the shared responsibility we have to protect our home planet. In an age of rapid technological advancement, the exploration of Venus serves as a reminder of the importance of sustainability and environmental stewardship. As we uncover the secrets of this neighboring planet, we must also reflect on the impact of human activity on our own environment. The lessons learned from studying Venus's runaway greenhouse effect provide valuable insights into the potential consequences of climate change on Earth. As we grapple with pressing global challenges, the exploration of Venus offers hope and inspiration. The pursuit of knowledge and understanding drives us to seek solutions to the problems we face, reminding us of our capacity for innovation and resilience. The stories of Venus are woven into the broader narrative of humanity's quest for discovery, urging us to remain curious and engaged as we navigate the complexities of our world. Continuing with our deep dive into the mysteries of Venus, we must also consider the implications of our findings on Venusian geology, and how they can inform our understanding of Earth and other planets. The study of Venus's geological history reveals a complex interplay of volcanic activity, tectonic processes, and surface interactions that have shaped its landscape over millions of years. One of the most fascinating aspects of Venus's geology is its extensive volcanic features. The planet is home to thousands of volcanoes, some of which are thought to be still active. The evidence for volcanic activity on Venus comes from radar imaging obtained by the Magellan spacecraft, which mapped the planet's surface in the early 1990s. These images revealed vast lava plains, large shield volcanoes, and intriguing volcanic structures such as coronae, circular features formed by volcanic processes. The presence of these features suggests that Venus has undergone significant geological activity in its recent history, potentially altering its surface in ways that are still not fully understood. The investigation of volcanic activity on Venus raises important questions about the planet's thermal history and its geological evolution. Unlike Earth, which has a dynamic plate tectonic system, Venus appears to have a more stagnant lid, where the surface does not recycle in the same manner. This stagnation could be a result of the extreme heat and pressure found on Venus, which may inhibit the movement of tectonic plates. However, some scientists propose that Venus may have experienced episodes of tectonic activity in the past, suggesting a more complex geological history than previously thought. Moreover, the study of Venus's geological features has implications for understanding climate change. The planet's thick atmosphere and extreme greenhouse conditions serve as a natural laboratory for studying how planetary atmospheres evolve over time. By comparing Venus with Earth, we can gain insights into the potential outcomes of climate change on our planet. The runaway greenhouse effect observed on Venus highlights the fragility of Earth's climate system and underscores the importance of understanding the factors that can lead to such drastic changes. Additionally, the geological history of Venus provides a valuable context for understanding the processes that govern planetary formation and evolution across the solar system. As we gather more data from missions to Venus and other rocky planets, we can begin to build a comprehensive picture of how planets like Earth and Venus diverged in their evolutionary paths. This comparative planetary science will enhance our understanding of what makes a planet habitable and how different environments can emerge based on geological and atmospheric processes. In recent years, there has been a renewed interest in Venus exploration, with several upcoming missions planned by various space agencies. NASA's Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, and Veritas, Venus Emissivity, Radio Science, in SAR, Topography, and Spectroscopy, missions aim to study the atmosphere and geology of Venus in unprecedented detail. These missions will provide crucial data on the composition of Venus's atmosphere, surface features, and potential geological processes, further unraveling the mysteries of this intriguing planet. The European Space Agency, ESA, is also preparing for its own Venus missions, including the Envision mission, which aims to investigate the planet's geology and subsurface structure. Envision will employ advanced radar imaging techniques to map Venus's surface, offering insights into the geological processes that have shaped the planet over time. These missions represent a collaborative effort to advance our understanding of Venus and its place in the broader context of planetary science. The significance of Venus exploration extends beyond scientific discovery. It also captures the public imagination. The mysterious nature of Venus, with its thick clouds and harsh conditions, has inspired a wealth of cultural narratives and artistic expressions throughout history. Literature, film, and art have all drawn upon the enigmatic qualities of Venus, framing it as a symbol of beauty, danger, and the unknown. This cultural fascination underscores the importance of scientific exploration in not only advancing our knowledge, but also enriching our collective human experience. As we consider the future of Venus exploration, it is essential to engage with the ethical dimensions of our scientific endeavors. The exploration of other planets raises important questions about planetary protection and the responsibility we bear as stewards of the cosmos. While the search for life beyond Earth is a driving force in space exploration, we must also be mindful of the potential impacts of our activities on other celestial bodies. The lessons learned from studying Earth's ecosystems can guide us in making informed decisions about how we approach planetary exploration and the preservation of extraterrestrial environments. The exploration of Venus also serves as a powerful reminder of the interconnectedness of all scientific disciplines. The study of planetary atmospheres, geology, and potential for life engages fields ranging from geology and meteorology to astrobiology and ethics. This interdisciplinary approach enriches our understanding of the cosmos and highlights the importance of collaboration among scientists, engineers, and researchers. In addition to scientific and ethical considerations, the exploration of Venus has implications for technology and innovation. The challenges posed by Venus's extreme environment have spurred the development of new technologies and methodologies for planetary exploration. For example, the design of landers and atmospheric probes must account for high temperatures and pressures, necessitating innovative engineering solutions. The advancements made in these technologies can have broader applications beyond space exploration, contributing to advancements in materials science, robotics, and environmental monitoring on Earth. As we reflect on the mysteries of Venus, we find ourselves at the intersection of science, culture, and technology. The exploration of this enigmatic planet invites us to consider not only what we can learn about Venus, but also what it means to be human in the face of the unknown. Our quest for knowledge is driven by curiosity, creativity, and a desire to understand our place in the universe. The narrative of Venus exploration is still being written, with each new mission and discovery adding to the tapestry of knowledge that shapes our understanding of this remarkable planet. As we continue to probe its depths and unravel its secrets, we embark on a journey that transcends scientific inquiry, connecting us to the larger human story of exploration and discovery. In conclusion, the exploration of Venus is a multifaceted endeavor that encompasses scientific discovery, cultural significance, and ethical considerations. As we stand on the brink of new possibilities, we are reminded that the quest for knowledge is an ongoing journey, one that requires us to remain curious, engaged, and responsible as we navigate the complexities of our world and the cosmos beyond. As we continue to explore Venus, we not only seek to uncover the mysteries of this planet but also to reflect on our own journey as a species. The stories we tell about Venus and the lessons we learn from its exploration will resonate for generations to come, inspiring future scientists, explorers, and thinkers to embark on their own quests for understanding. In the vastness of the cosmos, the mysteries of Venus serve as a beacon, guiding us in our search for knowledge and illuminating the interconnectedness of all things. As we conclude this exploration of Venus and its mysteries, we are reminded that the journey of discovery is far from over. Each new mission, each breakthrough in our understanding, opens the door to further questions and deeper insights. The legacy of Venus exploration will shape our understanding of planetary systems, climate change, and the potential for life beyond Earth, underscoring the importance of curiosity and collaboration in our pursuit of knowledge. The exploration of Venus beckons us to continue our quest, to seek out new horizons, and to embrace the spirit of inquiry that defines our humanity. As we look to the stars, we carry with us the lessons learned from our exploration of Venus, reminding us that the mysteries of the universe are waiting to be uncovered, and the journey of discovery is a path we all share. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.